So we are going to go over the practice problems that are uploaded in Module 2, Part 2 folder, and if you go to Homework and Quizzes folder, these are the practice problems for Module 2. So the first question says, there are two restaurants in a small town, Restaurant M and Restaurant B. A survey shows that 20% of M customers in this week will switch to B restaurant. If you are M, with the chance of 20% you will switch to B restaurant in a week, and 30% of the B customers will switch to M restaurant in a week. So what is then probability that an M customer stays with the restaurant M in the next week? 0.8. And what is the chance that the B customer stays with restaurant B next week? Is 0.7. And then, so this is our one-step transition probability matrix, which all of you should be able to do it in less than a second. If the market share for M restaurant is currently 50%, what is the M restaurant's market share a month from now? First of all, before we proceed, what is the time step in this study?
1 week.
It's a week. So the transitions happen in a week. If the market share for M restaurant is currently, if the market share for M restaurant is currently 50%, what is the M restaurant's market share a month from now? So first of all, when I talk about market share, what do you think that is? Market share of the M restaurant is 50%. So obviously for the B restaurant, the market share is the other 50%. But what is that value? What I gave you in this information?
You gave us the current state in week 4.
The situation of the state of the system right now. So I say market share right now is 50% for restaurant M. That means if I pick any restaurant in this, if I pick any person in this city, any person randomly right now, if I pick any person in this city, what is the chance that the person is eating in restaurant M?
50%.
That's 50%. That's the market share. So that's basically vector Q. So Q1 and Q2. So Q or QM, let's say, and QB. QM is the chance that the system is in state M. That means like if we pick any person, this person is eating in restaurant M, and QB is the chance that if you pick any person, that person is eating in restaurant B. So Q then is 0.5 and 0.5. So this is the situation right now. And we want to find the market share a month from now. Given that the time step is week, a month from now means 4 weeks later, 4 time steps later. So if I want to find the market share 4 weeks from now, I have to multiply Q by P4. And whatever I'm going to find here is going to give me the market share 4 weeks from now. So in this multiplication, what is the size of vector Q?
2 by 1. Or, sorry, 1 by 2.
1 by 2. How about matrix P4?
2 by 2.
2 by 2, because it's just matrix P raised to the power of 4. The size is not going to change. 2 by 2. So what is the size of the resulting matrix?
1 by 2.
Or 1 by 2.
1 by 2. Okay. So these two elements are going to be the market share after 4 weeks. Okay. So now Q is 0.5, 0.5, and P 0.8, 0.2, 0.3, 0.7 to the power of 4. So when we do this power and then multiply by vector Q, the results are going to be, I believe,
0.594 and 0.406.
Let's say 0.594441. Since I don't have enough space, I just round it. Okay, so then this shows that after just 4 weeks, the market share of restaurant M has gone from 50% to 59%. It has increased. After 4 weeks, the market share of restaurant B from 50% has gone to 41%. It has decreased. Okay. And then,
Sir?
Go ahead.
Yeah, I just have a quick question.
Uh-huh.
So when we're doing the p to the power of 4, like the matrix multiplying it by 4, should also the rows be equal to 1 by that time, or doesn't matter?
Yeah, and they still have to be, because P4 is the transition probability matrix in 4 steps. So if I ask you, for a person who is eating in restaurant M, what is the chance that the person switches to restaurant B after 4 weeks? The way to answer it is to calculate P4, and the elements of this matrix are going to be a 4-step transition probability.
And the rows would also be equal to 1 also by that time.
The same, yeah. The sum of the probabilities of each row equals to 1, and the elements of this matrix tell you that if you are at the state M right now, what is the chance that after 4 weeks you are still at the state M, or you are at the state B, and so forth.
Perfect. Yeah, I'm just making sure so like we can check your other work or something. Thank you.
Okay, sure. And then it says in the last part that find the market share of each restaurant in the long run. And whenever you see the long run or steady state and things like that, it always means the steady state probability. So for that section, we need pi 1 and pi 2. So pi 1 and pi 2 means that you let these restaurants, the people in the restaurant, make all their transitions that they can. Like they go from restaurant M to B, back and forth, back and forth, back and forth, and let all these transitions happen. And then when you look at the system in the long run, it's not that the system has a stop transition. It's still the system makes all the transition. It still continues the transition. But at any point, if you just stop the system and look at that instance, that snapshot, this percent of people will be eating in restaurant 1, and this percent of people will be eating this person will be eating in restaurant M, and this person will be eating in restaurant B. Okay, so still the transitions happen. Still people go from one restaurant to another, but the percentage of people that finally form the market share for restaurant M and restaurant B has reached to a steady situation. And then to be able to do that, we always use our famous formula, pi equals to pi p. So this equation is something that I have used many times in the videos and the homework and everything. But still, some of you were like pi p equals to 0 or something like that, and you solve for this equation. So I don't know what is going on, guys, but this is the equation that we have to use to find steady state probabilities. So pi p equals to pi, so pi 1, pi 2, multiplied by vector p equals to pi 1, pi 2. And then when we write the equations and delete one of them and bring the other equation, pi 1 plus pi 2. So let's assume I drop the first equation. So all I have is 0.3 pi 1 plus 0.7 pi 2 equals to pi 2. So that's the equation I'm going to keep, and then I bring the other one. And now I have two equations, two unknowns, and if I solve this, then pi 1 is going to be 0.6, and pi 2 is going to be 0.4. So if we let the system to make all the transitions and reaches to the steady state at some point in the long run, if I just stop this city and take a snapshot of people, 60% of people are eating in restaurant M and 40% are eating in restaurant B. So the market share basically from the 50% that was that is the situation right now. In the long run, the market share of restaurant M is going to increase to 60%, and for restaurant B is going to decrease to 40%, and that's basically the market share that we will see for this system.
Sorry, Professor. I think there's a little typo.
Where?
Isn't it for your system of equations? Is it
Let's
0.2 pi 1 plus 0.7 pi 2?
That is true, sorry. If you had made that mistake, I was going to kill you.
It was a test.
But since that's me, it's, yeah, row by column. Why I did that mistake, God.
The only reason I caught it is because I did that multiple times over the homework, so it's okay.
Renee did that last night when we were working on this.
But anyway, that's good. At least he could catch me. Yes, we multiply the first row by the first column. That gives us the first equation. First row by the second column. That gives us the second equation. Then we drop the first equation and add this other one. Thank you. Okay, so we have all of that. And then, and you had all of this in your quiz, right? So everyone is familiar with this part. Now, the part C is, did I put them? I think it's part D, right? Anyway, the next part asks, what is the mean first passage time from restaurant M to restaurant B? So first of all, let me ask, so for this 2x2 restaurant, which we have, M, B, point 8. Did I put B on the top? No. 0.8, 0.2, 0.3, 0.7, right? So if I want to write mean first passage time, what are the values that I can calculate? Tell me all the, just in terms of the notation, tell me all the mean first passage time notations.
M11, M22, M12, M21.
MMM, MBB.
Or that, sorry.
MBA, MBM. Okay, Rene, can you tell me what this means, MMM?
So the average amount of steps to get to when if you start from M and get back to M.
Yeah. So if you're eating at restaurant M right now, on average, for how many weeks, or on average, how many weeks would it take for you to come back and eat at restaurant M again? If you're eating at restaurant B right now, on average, how many weeks will it take for you to come back and eat at restaurant B again? So let me ask someone else. Abdullah, are you here?
Yes, Professor.
Okay, what is MMB?
So it's the average number of transitions from restaurant M to restaurant B. So we're looking at the average number from time we eat an M and we transition to restaurant B.
So if you are eating at restaurant M right now, how many more
weeks to transit to B?
To eat at restaurant B for the first. And MBM, if we are eating at restaurant B right now, how many weeks will it take for us to make a transition to restaurant B? And these are important from the marketing perspective for these restaurants to know, because they know, for example, if they need to offer any off value, anything, any offer, anything. If, for example, it takes 3 weeks for the person to switch to restaurant, if the person is eating at restaurant M right now and it takes on average 3 weeks before the person switches to restaurant B, they know that this is the time they have. The restaurant M knows this is the time that they have in which they can offer something or reduce the price or something to keep the person. Otherwise, in almost 3 weeks, the person will switch to restaurant B and we don't know when the person will come back again. So now, what is, so if I want to calculate what is the formulation, Kelsey? Go ahead, Abdullah, were you answering?
Yeah, 1 over the pi 1.
1 over pi m. And that was 0.6, right?
Yes.
And that is going to be 1.4.
1.67.
67. Yeah, so about it takes, if you are eating at restaurant M right now, it will take about 2 weeks or so before we come back and eat at restaurant M again. So guys, in the exam, when I asked you find the mean first passage time and explain what they mean, I want this type of explanation, clear, not like the number of steps that it takes to go from B to M and blah, blah, things like that. Like clearly, if we are eating at restaurant M right now, it will take us on average this many weeks before we come back and eat at restaurant M again. That's what it means. I want this type of explanation.
Professor?
Yeah.
I have a quick question. Would it be correct to say that at the time that they're not eating at that restaurant, they're eating at the other restaurant?
For see here, since these are the only two, yes.
So it's safe if I wrote it like that in a description, it'll be correct, right?
So saying that if you're at if you're eating at restaurant M right now, you will eat at restaurant B for 2 weeks before you come back and eat at restaurant M.
Yes, yeah.
Okay, yeah, you can do the same.
That's correct, right? Okay.
Yeah. BB 1 over pi B. What is that? 2.2?
2.5.
So John, what does this mean?
It takes 2.5 weeks before they eat at restaurant B again.
If they're eating at restaurant B right now, it will take 2.5 weeks before they eat at restaurant B again. And MB. Okay, let me ask. Analyst, are you here? Analyst? Anthony, are you here?
Yeah, I'm here.
Can you tell me how I'm writing MMB?
Yeah, so for MMB, it's 1 plus PMM multiplied by MMB.
Okay, so can you tell me your intuition behind this formula?
Yeah, it's the probability of MM.
So basically for going from restaurant M to B, it either happens in 1 week, we immediately go from M to B, or we go from M to M for another week, and then we go from M to B in whatever transitions it's going to take.
Professor?
Yes.
Yeah, so if we had like restaurant C, then we will add also probability from restaurant M to M times the probability times the MC.
Yeah. So yeah. Keep that question. Let's finish this and then do a 3 restaurant example together as well. Okay.
Thank you.
Sure. Remind me if I forget.
For sure.
So this is just one equation and one unknown, and so that's all we need. So MB equals to 1 plus PMM 0.8 MB. MB seems to be 5, I think. So that means if we are eating at restaurant M right now, it will take us about 5 weeks before we eat at restaurant B again. Right, correct. 0.2. Yeah. And then MBM. So can someone tell me the tuition? Okay, let me ask. Clarissa, are you here?
Yes, I'm here.
Can you tell me the formula for MBM? So the number of steps for going from, if we are eating at restaurant B right now, how many weeks would it take for us to eat at restaurant M for the first time?
So it's 1 plus probability of BB times MBM.
Okay, can you give me the intuition behind that too? So if I'm, okay, let me write this first. Okay, if I'm eating at restaurant B right now, I want to see how many weeks it takes me to switch to restaurant M, right? I either do it just in just 1 week, immediately go to restaurant M next, or I continue eating at restaurant B for another week, and then I'll go from restaurant B to M for the first time in whatever number of transition it's going to take. That's what this equation basically means. So that's one equation, one unknown. That's all I want. Bm equals to 1 plus PBB, which was I believe 0.3. No, right? No, BB 0.7. BM. I think it's 3.3, something like that. Right, 10 over 3. Yeah, so if you're eating at restaurant B right now, on average, it will take us about 3 weeks or so before we go and eat at restaurant M again. Is everyone okay with mean first passage time so far?
Yeah.
So far, yeah.
Okay, now the next part says, suppose that total annual restaurant profit in this small town is 1 million. So that's the whole profit in the town. Okay, so if M gets all the market share, that's 1 million. If B gets all the market share, that's 1 million. The owner of M restaurant is considering adding a new restaurant. Where am I? The owner of M restaurant is considering adding a new restaurant and to gain more market share and hopefully can make more money. The owner has done a study and found out that if the restaurant N is added. So then we are going to have 3 restaurants. For M customers, 10% of them will go to B restaurant and 20% of them will go to N restaurant in the next week. So if you're eating at restaurant M right now, 20% will go to N and 10% will go to B, and the other 70% will stay at M. For B customers, 20% of them will go to M, 20% will go to N, another 60% will stay at B, and for N customers, 20% of them will go to B, 20% will go to M, and the other 60% will stay at N. There is an additional cost of $100K for operation of the N restaurant should the owner open the new restaurant. So I'm not telling you what to calculate, what not to calculate. So tell me, what do you think we should do?
I would say find a steady state to see where the market share will eventually end up.
Yes, so that's our first step. So I have the market share in the 2 restaurant scenario. In the 2 restaurant scenario, this is my market share. 60% restaurant M, 40% restaurant B. Now the owner of restaurant M wants to create another restaurant N, and it's going to cost him 100K, but we want to see does it worth or not. So is it going to increase the market share or not if we open another restaurant? And if it's going to increase the market share, would that be enough to justify this investment? So now I have to find the new market share. So that would be another pi, p equals to pi. So here, what is the dimension of vector pi? What are the elements?
Pi 1, pi 2, and pi 3.
Pi 3, because I have 3 states m, b, n. I multiply it by p. Equals to pi 1, pi 2, pi 3. Now, if I want to write the equations, so the first row multiplied by the first column, so this row multiplied by the first column, so 0.7 pi 1 plus 0.2 pi 2 plus 0.2 pi 3 equals to pi 1. Then multiply this row by the second column is 0.1 pi 1 plus 0.6 pi 2 plus 0.2 pi 3 equals to pi 2. And then multiply this row by the third column of the matrix. So that's 0.2 pi 1 plus 0.2 pi 2 plus 0.6 pi 3 equals to pi 3. So then what do we do next, guys? How do you solve this equation, these three? So obviously I have 3 unknowns, pi 1, pi 2, pi 3. And I need 3 independent equations. But these 3 equations are not independent, are they?
Remove one of the equations and then replace it with pi 1 plus pi 2 plus pi 3 equals 1. And then you set the other 2 equations to 0, so you move the pi's over to the left side.
Yeah. So I remove the first equation. It can be any one of them. It doesn't matter. I chose to remove the first equation and I added this equation of pi 1 plus pi 2 plus pi 3 equals to 1. We know that. For the other 2 equations, I bring all the pi's to one side. And so that I have an equation equals to 0. And the same for the second one too. So if I want to do that, it's going to be pi 1 plus pi 2 plus pi 3 equals to 1, 0.1 pi 1 minus 0.4 pi 2 plus 0.2 pi 3. And the last equation is okay. So now I have 3 equations that are independent, 3 unknowns. I can solve it and find the value of pi's. And so we know how to do that.
1/3, and 1/3.
Okay. Pi 1 is 1/3. Is that, let me just, no. You said 1? You said 1, the values?
I got 1/3 for all of them, unless I did something wrong. I have an Excel spreadsheet that calculates it.
Wait. M and B. 0.2. 6.2. 0.1. 0.2. The values I have in my solution, they're different. Can you be the person who has done it wrongly?
I could be. I'm trying to double check it right now. I deleted off a different equation than you too.
It shouldn't make a difference.
Yeah.
Checking right now.
I want everyone to do this calculation. In the exam, we will have definitely a 3 by 3, if not 4 by 4.
I got 0.4 0.27 and 0.33.
See, John?
Yeah, I don't know. I gotta figure out what I did wrong because I've used this Excel for all the other homeworks and it's working fine.
Don't use that for the exam. That's all I can say.
Well, I must have just typed in numbers wrong somewhere.
I'm kidding. I'm kidding. Okay, so these are the numbers. 0.4. Let me just see them. If the yeah, I think the sum of these three. So the sum of pi 1, pi 2, pi 3 is 1. So these are pi 1, pi 2, pi 3. So the 1. So we said, remember, we said MBN. So that's the order. Oops. Here, MBN. So pi 1 is M, 2 is B, 3 is N. So in the first scenario, when we had only 2 restaurants, pi M was 0.6, pi B was 0.4. So the restaurant M then decided, the owner of restaurant M then decided to open a new restaurant N. They are going to pay 100K for this new restaurant. They want to know if they have to do it or not. So what is next? What should I go? What should I do from here? And overall, there is $1 million market share. Like, this is the whole money in the market right now. This 1 million is divided between restaurant M and B in the 60%, 40% portion. What is next?
We can calculate the profit that he gets before and after.
Okay, so right now the profit of restaurant M is 60% of this 1 million. So that's 600,000. So that's the profit before. So how do you calculate the profit after?
So we distribute
Add them together.
Yeah, so what is the market share for the guy who owns restaurant M?
But Professor, I got different numbers
For what?
for the steady state. They're the same numbers, just in different places.
Is you probably in different places, very sure?
Yeah, I got the same numbers, just that.
Okay, wait. M and B. Wait.
Mine are
yes, me
switched
too.
to.
Yes, wait.
Yeah, me too.
Yeah. M N B. N is point 33 and 0.264.
Yeah, that's what I got.
Yes, I just wrote the results, but based on the order I had. But the order I wrote here for the metrics is different from my answer, so that's why. Yeah, so these are the values. The market share for restaurant M, B, and N. Okay. Thank you, Ren. Can you guys tell me, okay, how do I then go with the rest of the problem? How should I know that if the restaurant M owner should do this or not?
We should add the probabilities of M plus N times the 1 million minus the 100,000. Then we can see if it's more than 600,000, then he should. If not, we shouldn't.
Okay, so for the owner of restaurant M, now the new market share is whatever restaurant M has and whatever this new restaurant N is going to have. So the new market share for this guy is going to be 0.736. That's basically 0.403 plus 0.333. So I added market share for restaurant M and N. This percent of that $1 million. So that's the money that the restaurant M owner is going to get. However, he also paid 100K to build restaurant N, So that is going to be 636, I believe, at the end. Minus, yeah, that's going to be this much. So the value of the profit, or it's going to go to from 600,000 goes to 636,000. So
A 5% increase, but they raised their market share. I'd say go for it still, because they go to almost 3/4 of the market.
yeah, I agree also. If I was their consultant, I would recommend it too.
Even though they only make 5% more, the market share goes up a lot more.
Yeah, the market share goes up. Yeah, and still it's 36,000, so it's not like nothing. Then all is good, guys? Any question?
Yes, all is good, but just reminding you for the 3x3 mean passage time.
Oh, yeah. Okay, so let's do this then. Okay, so mean first passage time for this one will be M, B, N, B, B, and and B. So these are the possible values that we can have for mean first passage time, right? So now, obviously, for any one of them, it's simple. 1 over pi m, 1 over pi b, 1 over pi n. Okay, so those one I'm not going to worry about. How about these other ones? So let's say for, I'm going to write here, m, let's say mb. So the person, so we are eating at restaurant M right now. What is the chance? Or no, how many? So after how many weeks we will end up eating at restaurant B for the first? So either I go from restaurant M to B in one transition, or I go from restaurant M to M, and then from restaurant M to B in whatever number of transition it's going to take. What is the other scenario? That is possible given the fact that we have 3 restaurants. We have restaurant M and B.
Going to N, then going to B.
Going from M to where?
N.
N. And then from
N
N, we go to restaurant B in whatever number of transition it gets for the first time. Okay? So these are the scenarios for going from restaurant M to B, either in one transition, or I go from M to M first, and then from M to B, or I go from M to N first, and then from N to B. So here I have one equation, and my unknown is M and B. So how many unknowns I have here in this equation?
I say
2.
How many?
2.
2. What are those?
MB and MNB.
Yes. Okay. The P is the one I get from the transition probability matrix, so I have those. So I have one equation, 2 unknowns, so obviously I cannot solve it. So then I have to write another equation for the other transition probability matrices for the other transition probability, the one-step transition probability values. So for that, I'm going to write M NB. So if I want to go from MNB, from I'm eating at restaurant N right now, and I want to see how many weeks it will take for me to start or switch to restaurant N for the first time. So I either go to restaurant M and from N to B in 1 week, or I go from restaurant, or I go from restaurant N. Jesus. I go from restaurant N to N, and then from N to B in whatever number of weeks it's going to take, or I go from N to M, and then from M to B in whatever number of transition is going to take. So that, okay, now this is a good equation, because now with these two equations I have two unknowns. So MB is obviously 1, so that's the green ones, and then NB, that's the orange one, is another unknown I have. So let me see, what is the P? The P, MBN. So if I want to write the P, if I want to write these two equations, so they basically are going to be MB is going to be 1 plus PMM, that's this one, 0.7 MB plus PMN, that's 0.2 MNB. The second equation will be MNB equals to 1 plus PNN. No, that's going to be this one, 0.6 MNB plus PNM. That's this one, 0.2 MV. So with that, I have two unknowns, two equations. Just move all the M's and MB's and NB's to one side and keep the ones on the other side. And similar to how you do solve the two equations for pi 1 and pi 2. So this is two equations, two unknowns. So just solve that, and then what you will find is MB at the end and MNB. Okay. So if I needed, so when I wanted to calculate MB, so this part is MMB, so I'm not worried about this part, but this part was the ones that I didn't have. So I wrote the equation for MNB as well. So that's the second equation. And it just turned out that since I have only two, so this one is just only a function of MNB and MMB. So that's because of that, I have only two equations, two unknowns. I can solve it and find the value of these two mean first passage time. You're going to definitely have one question with 3 possible values for the state, mean first passage time, and so forth. All is good?
Yes, thank you.
Sure. Next. So the question I gave you in the quiz, the second question was basically I basically asked you guys to put together the one-step probability transition for a problem statement. So at the time you guys didn't know that's an absorbing chain, but then the next videos were about absorbing chain. So let's look at that question again, and then after we put the transition probability matrix together, let's then answer some questions related to that. So I'm going to go to question 2. So it says that consider a prospective customer who has never been called about purchasing a product. After one call, there is a 60% chance that the customer will express a low degree of interest in the product. 30%. Okay, so the customer has either, so the way I have defined it here, no history, we have, or a new newcomer, new customer, anything. No history. I'm going to show it by NH. And then we call it the customer may show low level of interest, low interest, or high level of interest, high interest. And then at the end, we may end up selling the product. So that's the sell. Or we may end up delete the customer from the database. That's going to be D. Okay. So the problem statement says, consider a prospective customer who has never been called about purchasing a product. After one call, there is 60% chance, so there is the no historic customer. After one call, there is 60% chance that the customer will express a low degree of interest. So let me write it. So I want to put together the one-step transition probability matrix. No history, low interest, high interest, cell D. I'm going to put the same order for the columns. After a call, there is 60% chance that the customer will experience a low degree level of interest, so 0.6. A 30% chance of high interest, and a 10% chance that the customer will be deleted from the company's list. So that's 100% already. So 0% chance that the customer sells anything, and obviously 0% chance that the customer is again someone with no history because we already called the customer once. However, for the customers who already have a low degree of interest, after another call, there is 60% chance that the customer will purchase the product. Sell, that's 30%. 20% chance that the customer will be deleted. 30% chance that the customer will still have a low level of interest, and 20% chance that the customer will express a high degree of interest. And obviously the customer is not a newcomer, a no history customer either. For the customers that have high level of interest, after another call, there is 50% chance that the customer will have purchased. 40% chance that the customer will still have a high degree of interest. 40% chance that the customer will, and 10% chance that the customer will have a low degree of interest. So the chance of customer being deleted at this point is 0. The chance of going back to no history is 0 too, obviously. If a customer has purchased, is the sold option. So obviously the customer has sold, it's not going to change at all. So it's going to, the customer is going to stay in that state. If the customer has been deleted from the database, then the customer has been deleted from the database and there's nothing we can do. The customer is not going to go back to any other state at all. Okay, so that's the one-step transition probability. So a good number of you could not get that one correctly. So make sure to read the problem carefully. Make sure this is the very first thing I would want from you guys. Okay. So for every problem statement, you should be able to understand the problem, find out what is the characteristic of interest that is random, and what are the possible values for those characteristics of interest. These are possible values. And then what are the probability of transitions between these possible values. So now, tell me what are the transient states and what are the absorbing states.
Transient states are the first 3 rows, and the absorbing states are the last 2 rows.
Can you define what does transient mean? What is the definition of transient states?
They can still move between states. When they go into absorbing state, they are then stuck.
So we call a state as a transient state if there is a path that can take us out of that state and never let us go back. Those are transient states. So if there is a path for a state that can take us out of that state and never let us to go back to that state, that's transient state. And on the other hand, so these are the transient state. On the other hand, for the absorbing state, when we get to those, oh, sorry, here I have put D instead of 1. On the other hand, for transients, for the absorbing states, once we get to those states, we always are going to be there. We will get absorbed, basically. We are not going to move those states at all. So when we have absorbing states in a Markov chain, do you remember what was their main characteristic of this type of chains, absorbing chains? So in the long run, what will happen to this system?
They will get absorbed.
Yeah. For any customer, anyone who starts in this system at some stage, we let the calls to be made to these customers and so forth. At some point, any absorbing chain will finally end up getting absorbed in one of the absorbing states. That's always the case, okay? So one of the questions that is we really want to answer in this type of systems is that, okay, we know that we will finally end up in one of these absorbing states, but what is the chance that we end up here, sell the item? What is the chance that we end up here, just not selling the item, delete the number from our database? So those are important, actually, questions that pretty much all the call centers wants to answer. So this is just in a parenthesis. I have a friend who is a consultant for the Salesforce. Salesforce is a very famous and big consulting company in CRM, customer relationship management. These are big applications and software that they have. They install for the company, they customize for the companies so that they manage their customer relationships, the sales part and so forth. And as he was working on that, once I was with him, so I asked about one part that he is doing. So this was actually about the customer service of a software company, the project that he was working on. And then he said, yeah, here in this part of the app, so we have built a form that can tell them that if a new customer comes to the company when they want to sell the software that they are building, which I believe was the manufacturing software. So, and here we can tell them, like, if a new call comes in, they would call it actually a new lead. They said if a new lead comes in, what is the chance that this call, this number is going to end up buying the product? What is the chance that the person is not going to buy the product, or how many calls would it take for the customer to buy the product? And I was going to really scream, because I was like, oh my God, I teach these things. So obviously their work was not to calculate these things. These were the things that the company gave to them. Their work was just to create forms and things so that they can show all of these to the salespeople who were working with this system. But the fact that he was using this data, and I actually knew how these numbers were calculated, and it was just interesting for me to just see something that I do teach in a class that's actually is being used. So so basically the company was doing the same thing. So they had this so-called new lead. So they would call each number that they get a new lead, and then they would continue calling these numbers until they finally sell the product or they get deleted from the database. And they apparently were interested to know what percentage of these new leads will end up buying and what percentage of them will be deleted. Anyway, long story short, okay, we put the one-step transition probability matrix together. We can figure that this is an observing chain. We found the transient states and observing states. The first the first new question asks, what is the probability that the new prospective customer will eventually purchase the product? What is the chance that when I have a new customer, a new no history customer, a new lead, that person will eventually buy the product? So let's say then that helps the managers, because if in a specific year, let's say they say, oh, we get about 100,000 new leads. We go to conferences, we go to different markets and so forth. So to advertise this item, that this product that we have, we get about 100 numbers or 100 leads, 100,000 leads. What percentage of these people are going to buy the product at the end of the day? So if I want to answer that question, what should I calculate?
And how the IQ inverse times R.
Is that what you wanted to say right now?
Yeah, because you'll find you'll get the probability that a new customer will eventually get a purchase.
Exactly.
So 77%.
Slow down, man. So here, then I have to divide the one-step transition probability into 4 sections between transient and observing on the rows and on the columns. So this will be matrix Q, this is R, this is 0, and this is just nothing, identity matrix. So I minus Q, so that would be 1 0 0 0 1 0 0 0 1 minus Q, which is 0 0 0. So I minus Q inverse multiplied by R, and R is the one on the right side, it is 0 0.3, 0.5, 0.1, 0.2, 0. So that's I minus Q inverse multiplied by R. And if we do these calculations, we are going to get point. Okay, so that's the result. And just remember that this is for the first, these are the rows are for the transient state, no history, low interest, high interest, and the columns are for the first observing state, sold or deleted. Now, the question says, what is the probability that the new prospective customer will eventually purchase the product? What is that probability? A new prospective customer will eventually purchase the product.
70.5.
Yeah, for 1 1 NH to S.
Exactly. this is the chance that the new customer will eventually be deleted. So in this system, out of all these new leads, new customers that come to the system, about 70% of them end up buying the products, 20%, about 30% will not buy the product. If the customer has high level of interest, about 95% of them will end up buying the product, and 45% of them will end up getting deleted from the database. And this makes sense as we go from a new customer to low interest to high interest. Obviously, the chance of them buying the product increases. So then, for example, one other follow-up question that I can ask is that, oh, there is a marketing company that has come and talked to this, I don't know, this company, whatever it is, this product company, and they have found to talk to these customers such that, for example, these transition probability metrics, this is going to change. And I tell you, okay, with these new ways that they're recommending to talk to the customers, then if we have a new customer with the chance of maybe 40%, the customer will have a high level of interest. With the chance of maybe 0.05, the customer will be deleted. And with the chance of what's going to be 65% or 30, I don't know, whatever it is going to be. So that customer will have a low level of interest. So that's what I'm going to. So I say, okay, a new advertising company has come in, and with these new advertising methods, basically they are able to change these transition probabilities such that when we talk to a customer, the chance of them buying the product increases, the chance of them moving to the high level of interest customers increases, and the chance of them getting deleted decreases. And then I asked you the question that should the company do the investment in this marketing company or not, because the marketing company also is going to charge them some specific amount. Okay, so then the question is that should the company go ahead and do this investment, and how, for example, this investment will increase the chance or the percentage of new customers that eventually will buy the product, how that will increase the chance of the low interest level customers that would eventually buy the product, and so forth. So in that scenario, and it's like putting together another one-step transition probability metrics and calculate maybe these probabilities again, and then see if the market share or the percentage of people who will buy the product and things will change, and if that justifies the money we have to pay to the marketing company or not. What is then the next part, what is the probability that a prospect, okay, we answered that part. On the average, how many times will a new prospective customer be called before either purchasing the product or being deleted from the list? On average, how many times we have to call a new prospective customer before the customer finally gets observed, either buying a product or getting deleted from the database? How do I calculate that part?
You sum up all of the, you sum up the, what you sum up on the row that we're looking for in the I minus Q inverse matrix?
Yes. So I minus Q inverse, I'm going to calculate that, which we already have calculated for the previous section, but I just didn't write it. So I minus Q inverse is 1, 0, 0. Okay, so that's the result. And just remember that was for low, basically for no history, low interest, and high interest. And no history, low interest, and high interest. Okay, so it says for a customer with no history, on average, how many times a new prospective customer should be called before the customer finally gets observed? Either the customer buys something or gets deleted from the database. The answer to that question is basically the sum of all the elements of the first row. So that would be 1 plus 0.975 plus 0.825 and 2.8. So on average, we have to call a new customer or a new lead about 3 times before the customer finally makes a decision if the customer wants to buy an item or gets deleted from the database.
On the test, do you want us to round up to 3, or can we just leave it at 2.8?
Yeah, just leave it at 2.8.
Okay, cool.
On average, for a customer that has high level of interest, for how many calls the customer will stay with the high level of interest before the customer finally buys the product or gets deleted? For a customer that has high level of interest, for how many calls the customer will stay with high level of interest before the customer will finally get observed, either get deleted from the database or buys the item?
And the summation of the third row?
If you look at the summation, that's number of transitions or number of time steps that this customer has stayed in low interest transition, and number of steps or number of calls that the customer has stayed in high interest transition. But I said, my question was that for a customer that right now it has high level of interest, how many calls or how many transitions the customer will stay with high level of interest before the customer?
It's 1.75.
1.75. Okay, so read the questions carefully. I say how many calls it takes to finally go from high level to deleted from the database or sold. That's one question. Or I say go from customer who is high level of interest, how many transition or how many calls the customer will stay with high level of interest before the customers finally get observed. That's a different question. So make sure to read the question so you can answer properly. That's that. So for the customers who have a low level of interest right now, what percentage of them will end up getting deleted from the database?
30%.
30%. So for the customers that have low level of interest, 30% of them will end up getting deleted from the database eventually. 70% of them will end up buying the product.